Hello everyone, my name is Shalini, student of SVCE. In this video, I'll be talking about Anova. Here we have the contents. Introduction to Anova, explanation of one-way Anova, example scenario for one-way Anova, hypothesis for the example scenario, assumptions for one-way Anova, calculation of the F statistic, interpretation of the F statistic, calculation of p-value, example for one-way ANOVA, limitations and extensions of ANOVA, key takeaways. Starting with the introduction, ANOVA, analysis of variance, is a statistical method for analyzing differences between group means. It's used to compare the means of more than two groups to determine if there are statistically significant differences. Explanation of one-way ANOVA. Definition. One-way ANOVA accesses differences in the mean values of a continuous dependent variable among two or more independent groups. Assumption. It assumes that the populations have a normal distribution and equal variances. Example scenario for one-way ANOVA. Research scenario. An investigation into the effectiveness of different teaching methods on student performance in mathematics. Hypothesis for the example scenario. Null hypothesis. All teaching methods have the same effect on student performance in mathematics. Alternative hypothesis. At least two teaching methods have different effects on student performance in mathematics. Next, we have assumptions for one-way ANOVA. Homogeneity of variance. All populations have the same variance. The data must have homogeneity of variance. This assumption can be tested using Leibniz test for homogeneity of variances in the statistics package. Independence. Observations are independent of each other. The independent variable needs to have two independent groups with two levels. When testing three or more independent categorical groups, it is best to use a one-way ANOVA. The test could be used to test the difference between just two groups. However, an independent samples t-test would be more appropriate. Next, we have calculation of the F statistic. An F statistic is the ratio of two variances, or technically two mean squares. Mean squares are simply variances that account for the degrees of freedom, df, used to estimate the variance. F statistic are the test statistic for F test. Variances are the sum of the squared deviations from the mean. If you have a bigger sample, there are more squared deviations to add up. The result is that the sum becomes larger and larger as you add in more observations. By incorporating the DF, mean squares account for the differing numbers of measurements for each estimate of the variance. Otherwise, the variances are not comparable and the ratio for the F statistic is meaningless. We have the formula for F statistic, which is F is equals to variance between groups divided by variance within groups. Interpretation of the F statistic. Understanding. A high F statistic suggests that the means of the group are different from each other. Regression. In regression analysis, the F statistic tests the overall significance of the regression model. A high F value indicates that the regression model as a whole is statistically significant in explaining the variation in the dependent variable. General interpretation. In both cases, a high F value relative to the critical value indicates that the observed variation is unlikely to occur due to random chance alone, suggesting that there is a statistically significant effect or relationship being observed. Calculation of p-value. Determination. If the p-value is less than the chosen significance level, usually 0.05, the null hypothesis is rejected. The calculation of the p-value depends on the specific statistical test being used and the data involved. Common methods for calculating p-values include using tables, software packages like R or Python, or online calculators. It represents the probability of obtaining results at least as extreme as the observed result, assuming the null hypothesis is true. Next, we have the example for one-way ANOVA. Let's consider a question. Three processes A, B, C are tested to see whether their outputs are equivalent. The following observations of output are made. Carry out the analysis of variance and state your conclusion. Here we have the table of observations. Solution. To the table of observation, we add sum and square. That is, we add the observations row wise to get T1, T2 and T3. And square of T1 will be T1 square and T2 square, T3 square respectively. Adding T1 square, T2 square and T3 square, we get the total square value. And adding the T1, T2 and T3, we get the total T value. Squaring the table of observations, we get another table, and adding them row wise, we get the sum of squares. And adding all the sum of squares, we get the total, that is summation I summation j x I j square. As we have three processes, the k value will be 3, and counting all the observations of three processes A, B, C, we get n value as 19. Next, we have to calculate the CF using the formula t square divided by n, and TSS using the formula summation I summation j x I j square minus CF, and SST using the formula summation I TI square divided by NI minus CF, and SSE using the formula TSS minus SST. Here we have another table, source of variation, where the differences, that is k minus 1, n minus k and n minus 1 is written, and the SS values, that is SST and SSE values are mentioned, and also MSS, where MST is calculated using SST divided by K minus 1 formula, and MSE using SSE divided by N minus K formula. Finally, we find out the F ratio by using the formula MST divided by MSE, and the evaluated value of F ratio will be 1.106. Since the evaluated value of F ratio, that is 1.106, is lesser than 3.63 for F of 2.16 at 5% level of significance, hence hypothesis is accepted and there is no significance between three processes. Next, we have limitations and extensions of ANOVA. Limitation, it assumes normality, homoscedasticity, and independence, which may not always be met. Extension, advanced techniques like MANOVA and repeated measures ANOVA address multiple dependent variables and within subject designs. Summarizing the previous slides, one-way ANOVA is a statistical test used to compare means across three or more independent groups to determine if there are statistically significant differences between them. ANOVA assumes that the dependent variable is continuous and approximately normally distributed within each group. Homogeneity of variances, equal variances between groups, and dependence of observations. The null hypothesis in ANOVA states that there is no significant differences between the means of the group. If the p-value from ANOVA is less than the significance level, that is 0.05, we reject the null hypothesis and conclude that there are significant differences between at least two group means. Before interpreting ANOVA results, it's essential to check the assumptions mentioned earlier, such as normality of data and homogeneity of variances. Thank you.